Perfect. Yeah, we would change the title a little bit for the slides, but it's still the same thing. All right. So when we're thinking about agentic AI in regulated environments, we got a couple considerations, right? Regulated environments, naturally low trust, naturally low margin for error. We got to make sure that things are auditable and explainable. AI is not good at these things, right? We need a human in the loop. Problem is that human in the loop is not good today, right? So it's very rigid, right? Sorry, rigid on the end. Opaque, right? So we can't really see what's happening under the surface, right? We just kind of get one decision point, just kind of yes or no, right? Where we're noisy, we're getting this request over and over and over again, and we're rigid. So it's just always the exact same thing. Yes, you want to do this. No, you don't. Maybe you can snooze it for an hour or something, but you're not getting the level of granularity you want to really make good, effective decisions. Let's compare this to good human in the loop, right? It's contextual. When you look at a decision, you can see everything that's happening around it, and this can help you make the decision better. Not only that, it's stateful. A good human in the loop system is going to remember what has happened before. These two items, this gives you the auditability and the explainability. But for AI systems, we have to have them be reliable. This is how we're going to get them to be successful in regulated environments. All right, so introducing our concept, our patent pending framework, the Human Approval Loop, or HAL. That's a fun little name, yeah. All right, so let's talk this through. If we want to put human in the loop in the right place, in the right environment, we start with our simple scenario. User talks to LLM, talks to tools. We'll use MCP in this example, right? Here, there's no human in the loop. It just goes right on through, and whatever the LLM chooses to do, that's what happens. So let's add a human in the loop, right? We add a static review, simple yes or no. Works well enough, especially in low risk settings, but we have no auditability, no explainability, and again, it's very rigid. It's simple yes or no. So let's make it better. Let's add our HAL system. So now, whenever the user submits the request to the LLM takes this request, does what it needs to do, and then it asks HAL, is this approved or not? And HAL will take this request and compare it to previous requests. We'll talk about that in just a second. And it determines, are we approved or are we not? If it's not, it immediately goes to a human to review. So the human's still in the loop, but we have a much smarter way of identifying if we really need a human in the loop or not. And finally, we're right on to our tools and we continue like normal. So what is this HAL system and how does it work under the hood? Well, really briefly, we basically have a semantic similarity search. So very similar to RAG if you're familiar with that. A request comes in. The request is compared to a vector database of previous requests, right? So that's kind of the key detail. You're comparing your current request to everything you've seen before. If you have requests that are really similar in meaning, you head on to the next step. You're not just looking, are requests similar? You're looking for, is everything about the request similar? So that's your additional data. If you're asking for 2 plus 2, right, versus 50 plus 50, those might be really similar requests, right? But maybe those numbers are really important for why you're asking 2 different times in 2 different ways. So you'd have additional data that's helping you determine if these requests are similar, right? So that might be the type of user, the time of day, the types of MCP tools that are being invoked. Really anything you can think of, you can put as additional data. Now what the HAL system does is it goes through this. It says, hey, this is a similar looking request. It's similar additional data or similar types of data that we've seen before. We can approve this request because similar requests have been approved in the past. And if not, we immediately send it to human review. So we still have that human checking, but now we know that, hey, similar requests, we've seen it before, we can move along. And the magic of this all is that when this whole system is done, we funnel all the data back through into the previous requests and the additional data. So now we know whether we've approved or denied something, and we can send that data back so the next time we ask a question, it gets smarter and smarter. It can see, hey, we did this request in the past, we went through the whole process, and we can approve it. Excellent. Now we're going to talk about intelligent decisioning.
Thanks, Josh. So we talked about what good and bad human in the loop looks like. And in order to actually make HAL live, we use intelligent decisioning. And why we picked intelligent decisioning for these tasks is that it's it offers a dedicated layer of orchestration between all the components that we need to use for how to take place. So intelligent decisioning already has the capabilities for reading in data from systems and then applying human-in-the-loop mechanisms, so deciding where do we route it to a human, and it models that specifically to some pre-existing constructs that you can configure. It can also read additional data, so think about the similarity check that we mentioned as part of how you can reach into vector databases to perform that type of similarity check, and also apply additional models and rules in order to get those additional data insights that HAL can leverage. So those could be anything from policies that a human might want to use in their review process, or additional data from forms or any images or things that would support their decision-making process. Another reason why we picked intelligent decisioning as the first way to implement this was that we can deploy this flow to execute as an actual agent and give us results in a fast manner in real time. And then the outcome obviously is something like a recommendation for the human on what to do. And ultimately, it also provides us the mechanisms to define this both in code or in easy to interact with constructs that are drag and drop, low code, so anyone could access our system, our HAL system. Now, I'm just going to quickly introduce a simple scenario through which we'll demonstrate HAL today. Since we're in Texas and we're at this conference, we decided to look at a cowboy boot company, and they are dealing with a supply chain question. They, obviously, you see me, I already made my decision to wear my cowboy boots today. I have them on, but many participants at this conference maybe don't have them. So our cowboy boot company here in Texas got alerted by their agentic system that, hey, there's going to be an increase in demand. Everyone wants to wear cowboy boots at this party. So can I, I'm going to order a lot of boots for you. So normally the agent can do that, right? Like you have an LLM, it accesses tools, it makes the order to your vendors, but that's when the issue comes in, right? Like what if it orders too much? That can play a big role in your finances. It can also end up, what if it orders too little? Then your customers are not satisfied. So it has a very big impact on your operations. And for that, we're not going to let the agent act on its own. It will use human in the loop. Humans being inconsistent, maybe someone reviewed it last week and told the agent, yes, go ahead, or no, don't order, right? So we want to introduce these similarity checks to help that with additional context and so forth. So now David is going to show you how we're doing that.
Thank you, Diana. I'm going to go, before we go into the actual software, quickly go through the intelligent decisioning flow that will be powering all of that. You see at the top and the bottom the purple node that is our HAL implementation. So in the first step, it will take a look at the incoming request and compare it against previous requests to identify, based on similarity search, if we have something there where we can replay an existing pattern, almost like golden records in data quality. And if so, we follow down the left path where just those agents are directly available to us. We have implemented them here as sub-decisions, just so everything fits on one screen. If we cannot find a similar request, we go to the right-hand side, where we then have an LLM decide which agent is appropriate in order to get started on this request. And at the end of the whole circle, we have HAL again, because we might want to have some business constraints around what we automate, even if there's previously allowed requests. So let's say we have something like an order limit of 100K. If it goes above that, doesn't matter if there has been a previous similar one, we can still ask for human review. So we can balance that here. Quickly talking about the three agents, we have the forecasting agents, and you will see those two dots moving around because we are reusing the agents in both times, right? These are not separate implementations, and that helps us to forecast demand. The next agent is there to help us identify next best offers in one system because, again, if a human interacts with the system, they don't have just forecasting questions, right? They might have many different types of questions they ask. And then finally is the agent that can trigger ordering requests to our system. And on the very right-hand side is if we get a random request that we can't really handle with our agent, so we give an appropriate response to the user. So at that point, I'm going to end the PowerPoint and hope that everything just adjusts perfect. And we're going to, yeah. Yes. So here we are inside of SAS Visual Analytics, where we interact with this decision through this chat pane on the right-hand side. Now this is our supply chain agent, and we can start talking with it. And I have built it so it gives me prompts back so I don't have to type live, which is always hard to do. So we are asking it, hey, did any demand scans that need my attention come in overnight? And it goes in and tells me, yep, there is one that was up 340%. And it gives me a recommendation on from who we should order and also what the estimated cost of that would be if we need to air freight it because we kind of missed maybe because of a holiday or vacation time, we missed a longer term planning window. It then also gives me some context into that forecast to help me identify and make accurate decisions on here. And then it tells me, hey, you have three options. Either approve the full amount or modify the order to make it a bit smaller to kind of hedge my bets if I'm not sure if all of SAS Innovate participants will actually want to wear cowboy boots. I can adjust on that. Or actually I can completely reject this and ask it to reevaluate, try different forecast scans, maybe do some web search on the event more. As I said, I'm always returning the first option. No, in this case, I'm returning the second option as my prompt template just so I don't have to type it back here. So I am approving the second version, and that then tells the ordering agent to go ahead and place that order. And again, it tells me what to do. Now, my follow-up question is if there's anything else I should know about. And looking at its track and the logs that it has created for me, there is also a routine restock check that's going on here with only a very small amount of cowboy boots that we need for Denver. And in this case, because the order amount is so small and it's a routine one, it decided to just go ahead and place that order for me automatically, right? Because one, it has these previous examples of this type of request, and also we have some hard limits coded into the system just so that if a human makes a mistake one time, we still not make that now the default behavior of the agent or where we would have to go in and delete rows. We always have those checks and balances. And if we go over into SAS Intelligent Decisioning to take a look at this decision, this first node here, the vector database that is being used behind the scenes is SAS Speedy Store for that, which can run locally and is really high performant, but really any vector database can slot in here. And for the large language models behind those different agents, it's really using a combination of both open source and proprietary models like ChatGPT behind the scenes. Because while building this out, while I was building this, I noticed that the ChatGPT model just couldn't really deal with the type of data I got back from forecasting. So having that flexibility of choosing language models, It's also really important while you're building out a system like this and combining maybe local models for more sensitive data or to be more cost efficient at the end of the day. Well, that's a short walkthrough of how HAL can work. I'm not going to go into the actual code of HAL because that's thousands of lines of code. The good thing is that's why we are building that into our software, so you don't have to deal with that type of thing. So let me jump back into the presentation here and hand it back to Diana.
Thank you. Hello. Everyone can probably hear me anyway. Can you hear me? Okay, perfect. So I just wanted to have a couple closing thoughts. Obviously, this is not anything new. Currently, in highly regulated environments like financial services, in healthcare, and even in customer intelligence and experience, we actually have human in the loop as a mechanism to review this type of systems. The problem is that inconsistency, right, and the static behavior of it, and not having the context of how decisions were made. Many times in financial services, for example, you would review a transaction or a customer appeal, and as a human, you don't know what decision was made last week on a similar case by maybe another colleague. So having this type of similarity check becomes essential in order to be able to make consistent and reliable decisions. We, just to wrap up today, we talked about using intelligent decisioning as a tool to represent human in the loop with our HAL solution. And this is important because it is a tool that already is available to you in the enterprise today. The mechanisms that we use are flexible, and you can track the components that were leveraged there. It can map with your choice of LLM and of database where you represent those the similarity information. And also it enables you to take that entire flow from just the concept into production in a governed way. And if you're dealing with any issues like that, where you want to have human in the loop in your workflows, and it turns out that it's very difficult for humans to deal with the load of decisions they need to make and make them consistent, then don't hesitate to contact us. Unfortunately, there's no more time to talk about it in the Innovation Hub, but we are here for another few minutes, and you can also reach us at these email addresses, and we'll be happy.
All right, thank you guys so much for the presentation. Does anybody have questions? I'll be happy to run the mic and you can ask your questions. I also wanted to mention that there's a PDF of the slides in the app. So if you click on this presentation and scroll down to the bottom, it'll say attachments, and you can get a PDF of these slides. Yeah, I saw you taking pictures, so I want to make sure you knew that. Oh, I'm sorry. I should have said at the beginning. I didn't think of it.
Thank you for the presentation. And you'd mentioned that this is going to be coming into the intelligence layer. What is the timeline that that's going to be released?
Yeah, so we're exploring this as a concept right now, so we don't have this on the active roadmap. We want to understand what the most pressing use cases are and the most pressing products to receive this type of highly regulated technology. The reality is a system like this would be it would need a lot of configuration, right, to be effective. So we wouldn't want to just give this just anywhere and just see what happens, right? We really want to make sure that we're targeting those highly regulated environments and those really robust use cases.
Many of the components that you saw in decisions, in the decision flow, are available as part of the tool. The similarity check actually is something that we implemented through code. You saw that HAL node. So that's something that, we just picked one database that we saw as being very efficient, but we want to give an opportunity to customers like you to come to us and tell us, hey, I actually maintain this in my own database, so that will impact what we bring into the product for support. But the rest of the orchestration mechanisms and nodes that you saw there are generally available today.
I remember you have a tree go to the left side with all your agent, a different agent. Does it mean you really have to know the subject really well, anticipate a lot of things people may ask, and then you created a deterministic workflow so that you have the best answer to some of the prompt people ask? And then does it mean that's a lot of work, right? You have to really have an exhaustive list of the questions people may ask in order to have the list on the left.
Yeah, so if we really want to have the specialized agent, like here for forecasting, NBO, and ordering, you do need to understand how your people are talking to your systems. But the good thing is this is why we have this other node where if we don't classify something or we are unable to classify something, we put that out and then ask a clarifying question back to the user to specify, hey, I can do forecasting, NBO, and ordering for you. Everything else I'm currently incapable of doing for you. So we're kind of triggering the user with, this is what I can do right now. Now, in those specific sub-agents, yes, you need someone with the domain expertise to do forecasting, to do next best offer. You need to know how your ordering system works, right? But usually within organizations, there is already someone. What isn't the case is currently that they are kind of plugged together like this, that they are easily accessible. And that's where intelligent decisioning allows me to orchestrate those different departments, and they don't have to, like the NBO people don't have to talk to the forecasting people at all. They can all work in their own independent piece. They can update their models independent of each other. They can access different data sources from each other and collaborate through this overarching tree. That's the, yeah.
Sorry, another follow-up question. So it sounds like now you're just having the people asking questions based on all your data came out with a solution. What if I really want to link to all the latest market event that trigger certain conditions and then have the AI agent incorporated, link to your data, and then give appropriate analysis?
Yeah, so that really depends on how much you allow those agents to do. There is no limit to what you can do within intelligent decisioning. So if you want to do web search, for example, right, or look up the weather data and incorporate that, that is all possible within intelligent decisioning. You really have to figure out as a business, how do you do forecasting? What are important steps as part of forecasting, and what do I want to make available to my end users? Because maybe you have people that suddenly can start asking questions that they never even thought about. Now the question is, what of that are you going to support as a business as well, right? Because looking up data on the internet isn't, as one, it costs money, but also the question is then, how do you make people review that? Where do you have people interact with it? And that's how the system then evolves over time.
Any other questions? All right. Well, thank you guys for the presentation. Appreciate it.